Imagine a vast frozen desert, a place of relentless cold and unforgiving beauty. This is Antarctica, the Earth's southernmost continent. Now picture a gaping hole appearing in this icy expanse, a massive stretch of water open to the frigid air where there should be only solid ice. This is not science fiction. This is a Polynya, a mysterious phenomenon that has puzzled scientists for decades. In 2017, a gigantic Polynya opened up in the Weddell Sea off the coast of Antarctica. Its appearance sent ripples of concern through the scientific community. This was not the first time such an event had occurred, but its size and timing hinted at something unprecedented, something potentially dangerous. What forces could be at play to create such a dramatic alteration in this seemingly immutable landscape? Could this be a natural occurrence, a mere blip in the long history of our planet? Or is it a sign of something more ominous, a warning signal of the profound changes our planet is undergoing? The answers to these questions are crucial, not just for understanding Antarctica's future, but for the future of our planet as a whole. The word Polynya might sound like something out of a Jules Verne novel, but it's a very real phenomenon. Derived from the Russian word for open water in ice, a Polynya is an area of open water surrounded by sea ice. These patches of open water act as vital oases in the polar regions, offering a lifeline to marine animals that rely on access to the surface for breathing and hunting. While Polynyas might seem like random occurrences, they are often formed through specific processes. There are two main types of Polynyas, coastal Polynyas and open ocean Polynyas. Coastal Polynyas, as their name suggests, form near coastlines when strong winds push the ice away from the shore. Open ocean Polynyas, on the other hand, are more enigmatic. They form further out at sea, and their formation is often linked to the upwelling of warmer, deeper water. This upwelling can be caused by a complex interplay of factors, including ocean currents, wind patterns, and the shape of the seabed. Understanding what triggers these events is key to unlocking the secrets of these mysterious openings in the ice. The 2017 Weddell Sea Polynya wasn't the first of its kind. Back in the 1970s, a series of similar Polynyas appeared in the same region, captivating the attention of scientists around the world. These earlier events offered a glimpse into the powerful forces that could transform the Antarctic seascape. Researchers at the time struggled to explain these anomalies, limited by the technology and understanding available. Were these 1970s Polynyas a regular occurrence that had somehow gone unnoticed before? Or were they a sign of a changing climate, a harbinger of things to come? These questions lingered in the back of scientists' minds, even as the Polynyas eventually refroze, seemingly swallowed back into the icy expanse. The 1970s events served as a stark reminder of the power and unpredictability of nature, and the limitations of our understanding of these remote polar environments. They also sowed the seeds for further investigation, sparking a curiosity that would be reignited decades later. The 2017 Weddell Sea Polynya was different. It was colossal, dwarfing the Polynyas observed in the 1970s. At its peak, it covered an area 3 times the size of Wales, a staggering 60,000 square kilometers of open water in the heart of the Antarctic winter. This was not merely a large Polynya, it was an anomaly of unprecedented scale. The timing was also peculiar. The Polynya opened up in the dead of the Antarctic winter, a time when sea ice should be at its thickest and most extensive. This defied conventional understanding of Polynya formation. The 2017 Polynya persisted for several weeks, captivating the attention of scientists worldwide. Its sheer size and unusual timing raised a host of questions. What was driving this phenomenon? Was it a sign of a changing climate, a symptom of a warming world? Or was it simply a rare but natural event? The answers to these questions are crucial for understanding not just the future of Antarctica, but the future of our planet as a whole. The 2017 Polynya served as a stark reminder of the power and unpredictability of nature and the urgency of addressing climate change. The appearance of the 2017 Weddell Sea Polynya set off a scramble in the scientific community. Researchers around the world pored over satellite data, climate models, and oceanographic records, eager to unravel the mystery behind this colossal hole in the ice. The leading theory points to a phenomenon known as upwelling, This involves warmer, saltier water from the deep ocean rising to the surface. This warmer water, trapped beneath the surface layer of colder, fresher water, melts the sea ice from below, creating a polynya. But what triggers this upwelling? The answer likely lies in a complex interplay of factors, including wind patterns, ocean currents, and even the shape of the seabed. Some scientists believe that changes in wind patterns, driven by climate change, could be altering ocean currents, pushing more of this warmer, deeper water towards the surface. Others suggest that the shape of the seabed in the Weddell Sea, with its deep basins and underwater mountains, could be playing a role in funneling this warmer water upwards. The exact cause of the upwelling remains a subject of intense research, a puzzle that scientists are working tirelessly to solve. The Weddell Sea Polynya, while a dramatic event in its own right, is not an isolated phenomenon. It's a symptom of the interconnectedness of Earth's systems, a ripple in the fabric of our planet's delicate climate balance. The Southern Ocean, where the Weddell Sea lies, plays a crucial role in global ocean circulation. This circulation system, often referred to as the ocean conveyor belt, transports heat around the planet, influencing weather patterns and climate zones. The formation of large polynyas, like the one in 2017, can disrupt this delicate balance. As sea ice melts, it exposes the ocean surface to the atmosphere, releasing heat and affecting the salinity of the surrounding water. These changes can alter ocean currents, potentially impacting weather patterns far beyond the shores of Antarctica. The implications are vast and complex, with potential consequences for marine ecosystems, global sea levels, and even the planet's climate system. Understanding these connections is crucial for predicting and mitigating the impacts of climate change. The appearance of the massive Weddell Sea Polynya has fueled concerns about the impact of climate change on Antarctica and beyond. The Southern Ocean, surrounding the continent, has been warming at an alarming rate, faster than the global average. This warming is already having a profound effect on the region, accelerating ice melt, altering ocean currents, and impacting marine ecosystems. The 2017 Polynya, with its unusual size and timing, could be a symptom of these changes, a visible sign of the invisible hand of climate change at work. As the planet warms, such events could become more frequent and intense. The potential consequences are far-reaching. Increased ice melt contributes to rising sea levels, threatening coastal communities worldwide. Changes in ocean circulation can disrupt weather patterns, leading to more extreme events such as floods, droughts, and heat waves. Understanding the link between these polynyas and climate change is crucial for predicting and mitigating the impacts of a warming world. The mysterious hole in Antarctica's ice is a stark reminder of the power and unpredictability of our planet. It's a wake-up call, urging us to confront the reality of climate change and its far-reaching consequences. The 2017 Weddell Sea Polynya, with its unprecedented size and unusual timing, highlights the rapid changes occurring in the polar regions and the urgent need for research and action. We must invest in scientific research to better understand these events, their causes, and their potential impacts. We must reduce our greenhouse gas emissions to mitigate the effects of climate change and protect our planet for future generations. The time to act is now. The fate of Antarctica, and indeed the fate of our planet, hangs in the balance. Let the silent scream of the ice be a call to action, a call for global cooperation and a commitment to a sustainable future.